Hello everyone, am I audible?
Yeah, you're audible.
So hello everyone, I am Amaan and this class is supposed to be like a sequel of the previous class taken by Pranav on angle chasing. I'll just- Can you see my screen?
Yes.
Yeah,
So we'll be just looking at mostly some problems on angle chasing and in the end if we have time I'll introduce configuration as well. So can you see the problem on the screen? I think we can. This is an easy problem. Like to start off stuff with, we can start off with an easy problem. So I'll give you guys 2 3 minutes to try. If you have any ideas, you can say. Okay. So which I'll just start off with drawing the diagram first. ABCD is a cyclic quadrilateral. Yeah, I'll just draw it. Passing through A and B meets. Yes, meets here and B meets here. We need to show PQ is parallel to CD. So I think what Pranav even mentioned in the previous class was that some general strategies while you're angle chasing stuff is like try to look for cyclic quadrilaterals. That's like the first thing, like what can you see could be cyclic. So try to make guesses and look for cyclic quadrilaterals. I'll just try stuff right. And another strategy that I'll be emphasizing on in this class is like sometimes it helps to work with the problem backwards. So like you try to reduce stuff, assuming the problem is true, and try to reduce it to some stuff. What do you think could be possibly cyclic in this problem? Like what's a random guess?
ABPQ.
Okay, wait, can you repeat? Can like one person say at a time?
ABEF is cyclic.
Yeah, ABEF is cyclic is given in the problem, but like what could be another cyclic quadrilateral that you might guess just by looking at the diagram?
ABPQ.
Yeah, so that is a good guess. What would you do to like prove ABPQ is cyclic? Like, what angles seem the most easily computable in this figure? So one thing could be like proving these triangles equal. You can even work with maybe AQP and ABP as well.
Also, I guess CEFD can also be cyclic.
Wait, CEFD. Yeah, it could be cyclic, but mm, I don't think it'll be cyclic though.
I
Yeah,
mean,
it won't be.
APPQ is actually cyclic because
Yeah, yes.
QAP is same as like angle QAP is same as QBP.
Wait, can you repeat? QAB is same as?
QAP is same as
Oh,
QBP.
QAP is same as QBP. But how? How are they like how are these two angles equal?
I mean, see, like from ABEF, like from that cyclic quadrilateral, we
Hmm.
get FAE same as FBE.
FAE same as
FBE.
FBE. Okay, yes.
And from cyclic quad like ABCD, we get
Yeah.
ADC should be same as TBC. So essentially, if we just compare, so we get that result like ADP is same as, I mean, QAP is same as QBP.
Okay, okay. So DAC is DBC and then you're just subtracting them. Okay, yeah, that works. Cool. This works, yes. So she proved ABPQ is cyclic. Another proof, like what I had in mind, was to show these two angles are equal. That you can show by how can you write APC as like in this diagram, P and Q are the only weird points. A, B, C, D, E, and F are like related in a very good way because you can see two cyclic quadrilaterals like which are given to you in the problem. So how can you relate APC to angles which are being like which are uh, formed by the points A, B, C, D, E, and F? So how can you relate APC to that?
AB that APB angle is equals to 180 degree minus FAB and ABC.
180 minus FAB and
ABC.
ABC. Yeah, yes, yes. Yeah, this is correct, yes. And how can you write AQB as in a similar way? You can write this as 180 minus DAB minus ADE. Yes. So can you show that these two are equal? Like those.
Yeah, from the two cyclic quadrilaterals we have.
Yeah, because these two angles and these two angles are equal. So yes. So this is true. Now, so we have one thing that ABBQ is cyclic. Now, how do you proceed?
We can try to use corresponding angles like angle AQP is equal to angle ADC and like something like that. We can try to
Angle
use
AQB is equal to angle AD.
AQP is and ADC because
Yeah,
we
yeah,
prove
yeah.
it. So we can
Great.
use that and prove it parallel.
Oh, so how are you claiming that these two angles are equal? Like you need to show these two angles are equal to prove PQ parallel to CD.
Like ABC plus angle ADC is 180 and
Yeah,
ABP,
yeah,
like,
yes,
these
of
two are
course.
same.
Also, this was, I think, even Pranav discussed this in the previous class. Like this is what is Reims theorem. If you see these are two circles, they are intersecting at points, suppose X and Y, and these are like two lines. Then these two lines are parallel. This is what is happening here, if you see. In like the circles ABCD and ABPQ. So like FE is in fact, even FE is parallel to both of these lines. All of this stuff you get by Reims theorem. Do you see how I'm applying Reims theorem here?
Can you tell which circles are you applying it to?
Yeah, yeah. So first I'm applying it to ABFE and ABPQ. These are intersecting on common points A and B, and these are like two chords. So FE, like FE is parallel to PQ, and then I'm applying it on ABCD and ABFE. So FE is parallel to CD as well.
Okay, understood.
Did you get it?
Yes.
Yes. So yeah, so this was like a very basic example. Like it was just meant to illustrate that you need to find cyclic quadrilaterals in the problem. And then also we figured out that if you knew Rieman's theorem, then it could have been more simple to spot stuff. So I'll just bring the next one. So this is a slightly harder problem than the previous one. Please draw the diagram. To A and M and BT is tangent to omega. X is a point such that TV is equal to TX. Y is the focus from A onto this. Show AT parallel to XY. Just enlarge this one thing. Again, we should start off with like making essays on what could be cyclic here.
I think YTAX seems cyclic.
What YTAX? Actually, this is like, okay, you guessed it. So, but the thing is that you need to show AT and XY are parallel. So for it to be cyclic, it has to be an isosceles trapezoid. Do you think like it could be an isosceles trapezoid?
No.
Yeah, so that guess doesn't work. Okay, like firstly, there's a lot of stuff that's happening, and so we should like use every condition slowly. Like there are too many conditions which are given. So M is the midpoint as well. So first thing is that BT is tangent to this circle, like this random circle through A and M. So what angle conditions can you deduce from this?
ABY in the circle ABY. AB is the diameter, M is the
Yeah,
the center of
yes.
the.
Yeah, that's a useful thing. So I'll write it down here. So we have one thing that MB is equal to MA is equal to MY. We can write it like this. That M is the circumcenter of this.
Also, since T is tangent to the circle, so the center O will be parallel to AY. Like OT will be parallel to AY.
Oh, you mean MT? Oh, no, wait. O is the center of which circle?
ATM.
O is the center of omega. Okay. So I'll draw it as well. Okay, this is also one thing. Sure. So T is parallel to. But the thing is that you are introducing a random point O, and does it
Yeah,
help that much? I
yeah.
can't see.
If it helps, then.
How did we establish the equality between MY and MA?
Oh, so angle AYB
Oh,
is
okay,
90,
okay.
right? And it's like
Yes,
the
yes.
midpoint of the hypotenuse.
Okay, understood.
However, M is not the midpoint of BX, I think.
Yeah, it's not a midpoint of BX, it's the midpoint of AB, and AYB is a right angle triangle. Wait, I'll just write it here.
I guess if we prove that XYA is equals to ATO, like I introduced O, no? XYA is equals to ATO, then the lines XY and AT will be parallel.
Wait, what? XYA is equal to ATO. Yeah. Okay, yeah. If you prove that, then sure. Yeah, I think this could be a possible approach. But we also, like, you haven't used the condition TB equal to TX yet. So how like no
Yeah,
one thought
that
about that?
Message in the chat as well. Someone said TYXM is cyclic with some angle chase.
Yes, yes. So okay, that is like a good. Yes, that was what I was expecting. Okay, wait. TBM is equal to TXP is equal to BM. TBM is equal to TXP. BM. Okay, wait. I'll zoom on. Yes. Wait, how do you prove TBM is equal to BYM?
I think it is visible
Okay,
from
yeah,
YM.
yes, because that is equal. Yes, we have to. Okay, yeah, so that angle change works. So what he wrote is, I'll write it down here. Angle
I
TBM.
got the third line, like TXM is equals to BYM.
Oh, TXM is equal to BYM. Okay, so he wrote it in like a weird way. Okay, I'll just write it like this. So TXB is equal to TBM. This is fine, right?
Yeah.
Because and this is TBM is equal to BYM because of the first condition. This condition. Because
yeah.
this, yeah, so this is true. So TYXM is cyclic. Okay, so we have another thing, TYXM is cyclic. How do you proceed now?
Now I guess if we prove that XTA is equals to ATO, then we are done.
XTA is equal to ATO. Wait,
Because XTA is equals to XYA already.
no, XT is not, no, T, wait, XYT is not cyclic, XYTM is cyclic.
Oh yeah, yeah. Okay, sorry, my bad.
I think I have a solution now.
Yes, yes. Okay.
We need to prove corresponding angles are equal. YXA and TAM are equal. If we show this, then we are done. So
Wait, which angles are you showing? YXA and
mm,
TM. Okay, yeah, fine. Continue.
YXA and TAM, yes.
Yeah, continue.
So TAM and BTM are equal. They are angles in
Yes.
the
Okay,
the
so
alternate
wait,
angles.
I'll just explain it also. So does everyone get why TA and BTM are equal?
Yeah, it's tangent.
Because
So
BT is tangent. So yes. Now you can continue. Yes.
After this, as we proved, YTMX is cyclic, so angle YMT and angle YXT are equal.
YMT and Y. Yes. Okay, these are equal, right?
And angle TYM and TXM are also equal. So angle BTM
TYM
is
and
equal.
yes. Yeah,
Should I
continue.
continue? Angle BTM is equal to angle TYM plus angle TMY, exterior angle in triangle YTM.
Yes.
So from here, angle YXA is equal to angle TAM.
Okay. Wait, I'll
How
just.
do we prove that BTM is equals to YXT?
BTM is equal to YXT. Wait, BTM is equal to YXT. Oh, that is because this is cyclic. No, wait, BTM is not equal to YXT. Wait. I'll just repeat your argument again. So what he's saying is that BTM is TM is like till that point is fine, right? Also, you can like reduce your argument a lot. So uh, wait. This is cyclic, right? Like YT is cyclic. So these two angles are equal. Angle YXM and angle BTM. Does everyone see why?
Yeah, exterior angle in the cyclic quadrilateral.
Yeah, because like this is the exterior angle in this cyclic quadrilateral and this is the, so these are equal. And because BTM is equal to TM, we have already proved. So we have angle YXM is equal to angle TM. And this proves that these are parallel. Does everyone get it?
Yes.
Yeah. Nobody has issues, right, in this angle chase argument.
Can you repeat after the cyclic?
Yeah, I'll just repeat it again. So this is fine, right? TAM is equal to BTM.
Oh, no, I have
Yes.
a doubt.
Oh, okay. So this is because if you like look in this triangle ATM, BT is tangent to the circumcircle of this triangle, right?
Yeah,
And so like this is like whatever it's called, or what is it called, like the theorem I forgot.
alternate segment theorem.
Yeah. So by that these two angles are equal. Is it fine now? And after that, so this is one thing, and after that, YXM is equal to BTM because like YTMX is cyclic, and these two angles are equal. This angle is pi minus this angle, and so this angle.
Yeah, got it.
And just if you just combine them, you'll get this. So like in this problem, what helped was again you just needed to spot this cyclic quadrilateral. After that, it was very easy. So also like if you want, I could have motivated this even if we tried to work backwards. Like suppose you, okay, let me try that as well. So suppose like you try to work the problem backwards. Like you start off with assuming that AT and XY are parallel. So if you assume that AT and XY are parallel, then you know that these angles need to be equal. That you need to show somehow that these angles are equal. And then you say that TAM is equal to BTM because of the tangent thing. So that's how you figure out that TYXM must be cyclic. So it's not like a really random guess to show that this is cyclic. Does everyone get the backward motivation?
Yep.
So like
Yes.
right now when we are proceeding like in the straight direction, so it might seem random that how can we guess it's cyclic like just by looking at the problem. But if you try to work backwards, it's not like a really random guess. So now I'll just like bring the other problem. So now like this is significantly harder. Also, like, is the font of the proper size, or do I need to zoom in more?
Please zoom it a bit.
Oh, okay. No, like, what I'm writing, is it also small or just the text?
Question is a bit seems a
Okay,
bit small.
wait. I'll just enlarge it then. Mhm.
Click on the mouse button.
Oh, this, yeah, thank you. Is it fine now, or do I need to?
Yeah.
Also, are you checking chat if there are some questions, or do you want me to tell them?
No, I'm checking chat, but there are no questions.
Yeah, no, if the conversation.
But if you can like tell me what they are trying to say, that would be better.
Yeah, sure.
Okay, I'll just jot it down. So this is like the condition at first looks very weird. That if three lines are concurrent, you need to show that these two triangles are similar. So
In
what's
the
the first strategy like to prove two triangles similar? You show that their angle, because I don't want you to work with lengths right now. So what you need to show is the corresponding angles are equal. So was someone saying something?
Right.
is
Yeah,
O
go
the
on.
center of the circle here?
Yeah, O is the center of the circle, like which cuts AB and BC at the NF. What we need to show is three things. Oh, just two things. Angle EHF is equal to angle ABC and one of the other angles. Angle EFH, suppose this is equal to BC. Let's try to prove this first.
I got that. Can I say?
No, you can't.
I
Like
haven't
that.
done the problem before.
Just type it in the chat.
Thanks.
That is wrong. What you wrote, like EDC is not 180 minus ADC.
I meant ADF.
Oh, EDF, yes. Fine.
Yeah.
Yeah, that works. Does anyone have any ideas? How do you relate like EHF to other angles. H is the orthocenter. How can you use that? Okay, yeah. So as someone wrote, EHF is 180 minus EDF. Does anyone have issues in this? This was, I
Also,
think, yeah, continue.
to relate, then HEF is equals to 90 minus EF and DEFD.
Yeah. I am firstly like trying to prove this first. But yeah, I can write it here. That's fine. HEF is 90 minus EF. Yes. So by these two conditions, you have basically removed the orthocenter from the picture. Like you don't need to care about the orthocenter anymore. You only need to work with the points EDF. How can you relate EDF now to the other angles?
Can you please repeat?
Oh, I was saying that how can you relate EDF to like the other angles which are involved in the diagram?
EDFB is cyclic. So angle EBF would be pi minus EDF.
Yeah. So this is equal to angle EBF. And EBF is actually equal to ABC. So you have this, you prove this. Does everyone get this?
Yep.
Okay, so we have proved this in the first semester. But we haven't used the concurrency yet, if you see. Like we haven't even used that these three lines are concurrent. Now we need to prove this. This would require the concurrency.
First of all, I guess we need to shift EFD to EBD so that we can at least get into the scenario.
Wait, which angle?
EFD
EFD.
equals to EBD.
Yeah, that is one thing. Okay, I'll just continue this here. So this is equal to 90 minus angle EBD. Yes. Yes, that is true. So like you want stuff to be related to ABCD more because E and F seem a bit random. So this is true. This is fine. Yes. How do you proceed? How like so firstly you need to also bring in the concurrency point. Suppose I named it Z into the picture because we aren't really using the concurrency in any way. And also the circumcenter, like the center of the circle needs to be brought into the picture. What are the angles that could bring all, both these points together?
EDH is equal to ZDF.
EDH is equal to ZDF. How?
Because
Oh yeah, these are isogonal. Okay,
yes.
so wait, I'll just state this here, what you are saying. So wait, so does everyone know this that in a triangle, if ABC is a triangle, H and O are like the orthocenter and this circumcenter, so these two angles are equal.
Yep.
These are both equal to 90 minus angle B.
Yep.
Yeah, okay. So what we used is that only in the triangle DEF. So these two angles he's saying are equal. Yes. So I will just write it here. Angle HBE is equal to angle ODF. Yes. ZDF. Also, again, what could you like possibly think is cyclic here? And what might help?
I'm guessing that EHFA seems cyclic.
Wait, what? EFHA.
Yes, EHFA. I'm just
Even
guessing.
yeah. Even but the thing is that even if it is cyclic, it won't really help us because we need to bring Z and O in the picture. So try to find cyclic quadrilaterals that involve Z or O.
EDFA are cyclic.
EDFA. No, they can't be cyclic. EDFB is cyclic. Oh, he was just making a guess that EHFA is cyclic, although I don't think it would be cyclic, but I'm just saying that even if it was, it won't really help you.
ZDCF.
Yeah, okay, that is a good guess. ZD. It is actually cyclic. Now try to prove how.
I think I got it.
Oh, wait. You're not allowed to speak. Yeah, that works. Correct. Okay, so what angles do you think are like the most workable with in this, like to prove ZFCD cyclic?
I think here if we can prove that AZD is equals to FDC, then they can be proved.
Wait, what? Can you repeat? AZD is FDC, okay. DFC, you mean? What? Can you repeat what were you saying?
AZD is equals to FDC.
Oh, okay. AZD is equal to FDC. But how do you relate AZE to anything? That's
That
a
is
different.
difficult, like.
I think we should equate ZFD and ZCD. I think they
Yeah,
should
yeah.
be
Okay.
solvable, and
Yeah,
I do
okay.
not have the solution.
This is actually a good idea because if you see ZFD quickly relates to EFD and EBD. So you only need to like relate ZCD to stuff. Yeah, this is actually good. So let's try to prove this. ZFD and ZCD are equal.
Yeah, I got it. Should I
Yeah,
tell?
okay. Yeah, just say it.
ZFD is same as EFD. EFD is equal to EBD, which is ABD.
Okay.
So ABD and ACD are equal. So ZFD is
Yeah,
equal to
yeah,
ACD.
yeah, yeah. Yeah. Okay, I'll just repeat it. So what he said was ZFD is equal to EFD and EFD is actually equal to EBD because EBDF is cyclic. I'll just write everything here. Where do I write this? Okay, clear this off. So EFD is equal to angle EBD. And angle EBD is equal to angle ABD, which is equal to angle ACD. And ACD is basically ZCD. Does everyone get this? Like this whole angle system? Why can't I make this? Yes, like this whole thing. Does anyone have any issues here? Let's just do a poll. Enough, can you make a poll?
Yeah.
If anyone has any problem, I'll just repeat the whole thing.
It says for problem 2, but like assume it's for this problem. Doesn't matter.
Oh. Assuming like whoever just got ZF CD cyclic, you can proceed like with the problem. You need to show ABC and like these, you need to show this. So try to relate EFD to ACB now.
Everyone, yes, like half of the people responded. You can see the poll results, right?
I was able to, but I'm not able to see it now.
Click on polls and project option.
Okay, I can see it. Yes.
It will be nice if the other half people can just make it.
True.
Also, if you have a question, like feel free to ask.
Yeah, just unmute and ask. For the other people, like how do you use this ZFCD being cyclic to get some stuff, nice stuff about this quadrilateral? Also, we haven't used that Z also lies on DO yet. Like you haven't really brought O into the picture. Can you give me like 5 minutes? My headphones are about to discharge.
Yeah, I think I solved the rest of the question.
Can you please tell until he comes? I guess you can then.
Yeah, so like because ZFCD is cyclic, ZCF will be equal to FDZ.
Okay, can you
just-
repeat? I was like, no.
Yeah, I'll just repeat.
Yeah,
So
yeah.
now that we have ZFCD as cyclic, ZCF would be equal to FDZ.
ZCF would be equal to FDZ, yes.
And yeah, and now O and Z are actually collinear. So FDZ is actually just equal to ODF.
FDZ is equal to ODF. Yeah.
Yeah. So now because EFD lies on the circle, ODF will be equal to 90 minus FED.
Yeah.
So that and if you look at ZCF, that's actually just ACB. So
ZCF is actually just ACB, yeah. So you
yeah,
get
so you
AC
complete the
perpendicular.
proof, yeah.
You get AC no, you're not done yet, but you get AC perpendicular to BDI.
Sorry?
Wait, how do you complete? Wait. So you prove that this is 90 minus this, and you after that.
So yeah, so basically then EFH is actually just 90 minus FED or DEF, and
Yeah.
then if you
Oh, okay,
that's
yeah,
that is, it just becomes the same
yeah,
thing.
yeah. So I'll just repeat what he said. So after like proving ZFCD is cyclic, what he said is that angle ZFD was equal to like angle ZFD is equal to yeah, sorry, my bad.
ZDF.
Yeah. Angle ZDF is equal to angle ZCF is equal to angle ZDF because it's cyclic, and ZDF is actually equal to angle ODF. And O because O is the circumcenter of EFD, so ODF is equal to 90 minus angle DEF. Does everyone get this right till here?
Yeah.
Okay. And 90 minus DEF is nothing but 90 minus yeah, okay. And 90 minus DEF is nothing but HDE. Yeah. HDES. Or wait.
Should I repeat? Should I repeat or like?
Yeah, just repeat it like what?
Yeah, so I'll just yeah, once you get angle ODF as 90 minus DF,
Yeah.
so then notice that basically that's equal to angle ZCF, which is equal to angle ACB. So
Yeah.
and basically 90 minus angle DF is basically just angle HFE. So because H is the orthocenter, and so you'll get basically angle HFE is equal to angle ZCF, which is equal to angle AC.
Works. Yes. So 90 minus DEF was equal to HFE, and this is equal to ZCF is equal to ACB because this is linear. So this works. Also, like this gives AC perpendicular to BD. So this quadrilateral was not very random.
I just want to ask: is there a solution with like a sine rule for this problem? Because it looks very length bashy.
I'm not totally sure, but I think there should exist one.
Okay.
You can try it. I think they should. I can tell you the source if you want after the class.
Yeah, okay, that would be helpful. Thanks.
Does everyone get this? Like this whole thing?
Yep.
Yes.
Okay.
Also, some person said they have a doubt in some steps.
This
So
problem is from which contest?
I'll just share the sources after the class. I don't remember them right now. Yeah, what problem did you have?
I don't know. They just marked in the poll that they have a problem.
Oh.
So whoever, and you can ask.
If you have any problem, just unmute. Or it might be for toll purposes. Who knows?
Yeah, I think we can continue. If they have a problem, they'll learn.
Yeah. They'll just unmute. So like again, the emphasis was on proving stuff is cyclic, and yeah, just making random guesses helps. Yes. I'll just bring in the next problem. No, before this, I need to like, mention some stuff. So let's first do some easy stuff before this. So ABC is a triangle, and H is the orthocenter. You might have already seen all of this. M is the midpoint of BC, and A dash is like the reflection of A and M. So first thing you need to show is that BHC A dash is cyclic. Second thing you need to show is A dash is the H antipode. Does everyone know what an antipode is?
I don't know its meaning.
Okay. So like if ABC is a triangle and the A antipode of the triangle ABC is like the diametrically opposite point of A in the circle ABC, a circumcircle of
Okay.
ABC. Okay, do you get it now?
Yeah.
So A dash is like the H antipode, which means like it is the diametrically opposite point of H in the circumcircle of the triangle BSC. Also one maybe okay, I'll just tell it right out. First try to prove these two things. Does everyone get like the problem?
Yeah. I think here we can easily prove cyclic if we notice that A dash C is a parallelogram, and then using the
Yeah.
we can easily prove it.
So like A dash C is a parallelogram. Is it like, does everyone get it? Why is it a parallelogram? Because like M is the midpoint of BC and A dash. So
Yeah.
and because this is a parallelogram, so BA dash C is angle BAC. And this is equal to 180 minus angle BHC. So this is cyclic. So this we have proved. Does everyone get this? If you
Now
all
we
get
How did
this.
we
Yeah.
complete after showing that it is a parallelogram?
Okay, so after that, after it is a parallelogram, these two angles are equal, right? BA dash C and BAC.
Yes.
And BAC is 180 minus BHC because BHC is 180 minus BAC.
Oh, okay.
Okay, so this is like these are supplementary.
Yes.
Now you need to show that it is the H antipode.
I'm done with the second part too.
Okay, I'll say it.
Can I speak it?
Yeah.
So HBC is we know 90 minus C because we can drop a perpendicular and we'll easily get it 90 minus C.
Yeah.
And we need to prove that A dash BC is angle C. We know that this is true because it is a parallelogram.
Okay. So what he said is angle HBC is 90 minus angle ACB and angle A dash BC is equal to angle ACB because it is a parallelogram. These two angles are equal. Does everyone get this? And so if you add them like if you substitute this here, you get that this whole thing is 90 degrees. Does everyone get this?
Yeah, clear.
Wait, okay, this should be fine now. I can just give the problem now. This is actually quite hard. Okay, so now for this problem, like what would help would be to like think about it backwards. Like how would you prove this MHE is 90? Like what would you relate it to?
Is GHMB cyclic, maybe?
GHMB.
Yeah.
No,
Yeah,
it
it
can't.
seems.
It seems, but wait, I'll have to think about it.
Oh, yeah, it can be because it's 90, obviously. So
Yeah, but no, it could be still, but I don't think it will be. Yeah, it won't be.
It will be only when ABC is 90 degrees.
Yeah, maybe that's true, yes. Okay, so you have too many conditions here. Like, firstly, one first thing you already see is that AP is parallel to BC, right? So this is 90 as well. So even HGP is 90. Does everyone get this? How?
Yeah, pH is the diameter, we can call it like that.
Yeah, pH is the diameter, yes. That is a good way to say it.
Are we working it backwards or?
I'm just like, I'm just pointing out stuff first. So pH is the diameter. Like
Yes,
whatever,
yes.
what can you just see like straight away from the conditions?
Okay.
Just say it all.
Parallel to MH.
What?
PG is parallel to MH.
So now you realize like you need to show PG is
Yes.
parallel to MH. Like if you try working backwards, so you need to show this. Also, you have to use the fact that M is the midpoint of D dash as well. So there are too many midpoints involved in the picture.
Can we do it something like this? GPH, we need to show that GPH is equals to MHP, MHD dash. Is that what we
Wait,
want?
what? GTH or GDH?
GPH is equals
Oh,
to MHD dash.
MHD dash. Okay. Yeah, okay. Wait. GPH, those won't be equal, right? MHD dash is equal to, I'm not sure. How are you like working it backwards here? Can you explain?
No, I'm just like to make the angles in the triangle ABC so that I can convert them.
Yeah,
Like
yeah. So can you repeat your argument? GPH is equal to
MHD dash.
MHD dash. How?
Because we need to prove that they are parallel now. So
Oh, okay. You are just saying, yeah. Oh, you are trying to work backwards, yes. So MHD dash, yes.
and we also know that GPH is equals to GAH, which is equals to 90 minus.
Yeah. 90 minus angle ABC. Yes. So you need to show, okay, yeah. So this was a very, okay, wait, I'll just read the chart first. Question of yes. BHCT and BHC. Wait, what is T? Whoever wrote in the chat. I think it means X. No, it doesn't. Can you specify what's T? Okay, but I'll just BHCX are parallelograms. Okay, yes, sure. So what he's saying is, I'll just introduce this point X like this and DHD. Okay, yeah. But I'll just repeat what he said first. So what he said was we need to show GPH is MHD dash, right? Because we are trying to work backwards. So GPH is MHD dash and GPH is equal to GH, which is equal to 90 minus ABC. So what we need to show is that 90 minus angle ABC is equal to angle MHD dash. In this way, you have basically eliminated like P and G completely from the picture. If you see, you just need like only the points A, B, C, M, D, and D dash. That is a good thing. But maybe you do even need P still. So I'll not recommend you to like remove it completely. But you can try working with this first. Also, what he mentioned, okay, so what the other person mentioned was like if we introduce the reflection of H in M, suppose it is X, then he's saying that BHCX is a parallelogram and even this is a parallelogram. Does everyone get why? Because M is the midpoint of HX and DD dash and BC.
Yeah.
So even I'll just write it here. X is reflection of H in M. B H E X. This is another thing which may be useful. Whatever claims you have, just throw them in.
Oh yeah, X is the antipode.
Wait, what X is the antipode in of what?
A.
ABC.
Yeah,
ABC.
okay, yes, that's true. That was something I was like willing to share before this, but yeah. So how is X the antipode?
I think we can show this by seeing that in triangle HBC, A is the orthocenter,
Yes,
and then by using the property we described above.
yeah, that is correct. So
Uh,
does everyone get what he's saying? So he's like basically indexing the whole thing with H. Like he's focusing on the triangle BHC. So like in triangle BHC, A is the orthocenter. And then we use the claim that we stated above. So we use this. Does
Can we
everyone?
somehow prove that XB, H, and D dash are cyclic?
Wait, XB, H and D
X,
dash.
XB, H, D dash, yeah. Then I guess we'll be done.
Okay, how, matlab, like, how are you reducing it? Proving XB, H, D dash is cyclic?
Yeah, that is what I'm asking. How if we can.
No, if assume that it's true, then how are you proceeding after that? Assume that it is cyclic.
Then we have got already that 90 minus AB is equals to MHD dash. So MHD dash will be equal to XHD dash is equals to XBD dash, which is actually 90 minus ABC.
Wait, XB, D dash is the same 90 minus. Yeah, okay. 90 minus ABC, yes. Okay, so what he's trying to say is that you need to show this is cyclic. Yes, this is correct. So does everyone get how is he like reducing it to proving this is cyclic? So what he said was, I'll just repeat it. Angle XHD dash is equal to angle MHD dash is equal to angle XHD dash because these are collinear. And XHD dash is equal to yeah, and if we show that XHD dash is equal to XBD dash, assuming this is cyclic, then xpt dash is equal to 90 minus angle ABC only. Because this is the anti-force. So he is like, he has reduced it to proving that BH D dash X is cyclic. Does everyone get like what he said?
How did we say XB D dash is equal to 90 minus ABC?
Oh, because X is the antipode. So XBD dash is XAC,
All
which
right.
is OAC, and 90 minus ABC.
And above, how did we say 90 minus ABC is MHD dash?
Oh, we didn't say it like I wrote. We need to prove this. We are
Okay.
working backwards, right? So we
Okay.
first needed to prove this, then we reduced it to this, then we reduced it to this.
Can you see the problem?
Oh, yes. Okay.
Yeah, now it's fine.
So now we are just left to show that BH dash X is cyclic. Or if someone has any alternate approach, they can say that as well.
Would it be possible to prove that GH is parallel to BC?
BH is what?
GH is parallel to BC.
That won't be true, right? Because GHM we need to show is 90.
It is
So
GHM.
that would mean that HMB also has to be 90. Do you get it? Like what I'm trying to say?
Yes, yes.
Okay. Another way was like what we initially started off with. PG is parallel to MH, and how can we BD dash X is BGH are collinear. What? Yeah, this is not true. Wait, what did you say? BD dash X is HGT dash is wait, BD dash X is HDD dash. How is okay? Yeah, that is because it's a parallelogram, and this is equal to BHM. You're saying no, 90 is not equal to BHM, right? Assuming they're cyclic, how is it equal to BHM? Oh wait, was this yeah, right. Now I get what you're saying. Yeah, okay, so this is, I think there is a bit of a mistake here. Let me just see. Said MHD dash is equal to, assuming they are cyclic, and the x, which is equal to this, which is equal to 90 minus ABC. Yeah, okay, I think there is a fault here only. Like even this is a fault. That is GPH equals MHD dash. But then minus ABC minus 2 dashes GH.
Does G lies on AB?
No, it doesn't. I think yeah, there is a fault here. Wait, I'll just check it out. But you guys try, like, apart from this, there is a fault there.
Oh, G doesn't lie on AB. I did it like that.
Yeah, I think that you assumed that, like, in this. Yes, you did assume this. So this is right. This is not true. Okay, yeah, so we needed to show that PG. Okay, yeah, the X is a useful point though. Like all of this stuff is useful. And we needed to show that PG and MH are parallel. How can you use that M is the midpoint of DD dash? Like you, while keeping P in the picture. I think it's fine. He was just trying to verify the claim. Okay, yeah. Also, like from the previous claim, let's try to just introduce A dash also in the picture. Right. So what we like saw in the previous configuration, A dash, suppose A dash is the reflection of A and M. So we have that BHC, A dash is cyclic and all that stuff. Also, can you see now that A dash would lie on PG? Does anyone? Okay, so I'll write it here. Let's try to prove this.
We need to prove that AGH is also 90.
A dash GH, yeah. And that is true because of the previous claim, right? Because A dash was the H antipode.
HBC antipode, yeah.
Yeah, so that is true. So angle A dash GH is 90, which implies the claim. Does everyone get this?
Yeah, I got it.
Okay. Now, so M is the midpoint of A dash, right? And you need to show MH is parallel to PA dash. What does, like, if you look in the triangle AP A dash, what does this remind you of? Like M is the midpoint of A dash, and you need to, like, this if you extend it, it should be the midline, right?
Can you repeat?
So M was the midpoint of A dash, right? Like by the definition.
Yeah.
Yeah, and you need to show MH is parallel to PG.
Yeah.
So MH needs to be the midline, right, in this triangle A dash P. Because M is the midpoint and
I didn't get what you meant by midline.
oh, okay. Yeah. So like the A midline is basically the line joining the midpoints of the sides BC, AB and AC.
Oh, okay.
Yeah. So if you extend it and like if you let it meet AP at a point X, then you need to show X is the midpoint of AP, right?
Can you name it X dash? It's a bit confusion because we already
Yeah. Okay, X dash. Wait, I'll just rename it to T. We need to show this. And how we have defined T is MH intersection AP.
We need to show that T bisects AP.
Wait, can you repeat? I don't hear you.
That T is the midpoint of AP.
Yeah, because M is the midpoint of A dash and we need to show MH is parallel to PG. We have already shown that PG passes through A dash. So we need to show that MH intersects AP at the midpoint of AP. So we need to show T is the midpoint of AP.
So we just need to show that MH is okay, right. My bad. I was just saying that MH is parallel to GB, but that is what we need to prove.
That is what we needed to prove. And because M is the midpoint of A dash and PG passes through A dash, so we need to show that MHT is. Also, we again haven't used MD is equal to MD dash here. What can you see in like?
I think THB and HMD dash are similar, and as well as HDM and HAT are also similar.
Wait, can you repeat that?
So HTB and HMD dash are similar. As well as,
HTP and yeah, HMD dash are similar, yes.
and HDM and HAT are similar.
HDM and HATS. Okay, so that's correct. Triangle HTP and HMD dash. Triangle HAT and HDM.
Yeah, so now we are done, I guess.
Yeah.
Then you can use like the similarity.
Yeah, you can just use the similarity ratio. You'll get this is the midpoint.
Yeah.
Do I need to do that or does everyone get it?
No, we are done. Right? Yeah.
Just a minute. How did we complete after this?
Oh, okay. I just write the similarity. So this is fine, right? These two triangles are similar.
Yeah.
Okay, so I'll just write the length conditions. AT upon DM is equal to H upon HP and is equal to HT.
I got it.
Yeah. Still, I'll just okay if everyone has got it then. Do I need to do this? I can do this. Like it
It's
No,
just DM and
yeah,
D
yeah,
D dash M are equal, so PT and TA are equal, right?
yeah. Because these two triangles are similar. Yes.
Yes.
Like so, if we had just like seen this problem like without knowing what the anti-code lemma you mentioned
Yeah.
before.
So I was like going to motivate this now. So the thing was that if you would have not seen this first, then it would have been very hard to like even guess a dash, to bring a dash into the picture at the first place. So like that was what I was trying to convey with this problem, that if you know some certain configurations from before, then it usually helps a lot. So that like you could have just introduced a dash right away if you knew this claim from before. Although I think I'll try to work with X as well. I'll get back to you. I think there should be a solution using this.
Okay, fine. Thank you.
Does anyone have any doubts like in this whole thing?
no doubts.
Yes. I think I'll just end here. I'll send the sources after the class, and you guys will get a preset, I think, for this.
So
I'll just
that,
give harder problems in that.
also ABC EHF problem was USCMO 2019 P1.
Oh yeah. This is USA 2019. What problem?
Problem 104. Problem
Yeah.
pretty sure it's problem 1.
Also, this is Elmo. I don't remember which year. It's recent only. I think 2020 P4 or something.
Yeah, also, okay, I'll stop recording and class is over, right?
Yeah.